Assalamu alaikum wa rahmatullahi wa barakatuh. We give thanks to Almighty Allah. We want to continue from our topic, and today we are going to Theorem 9. For the Theorem 9, what we are to prove here is that we want to prove that the straight line joining the midpoints of two sides of a triangle is parallel to the third side and equal to half the length of the third side. That is, from what we have on the board, look at this. We have two triangles here. The first one is triangle ADE, and the second one is triangle ABC. What we are now saying is that this straight line, this line that we have here, which is DE, will be what? Equal to half of the line BC. In other words, if this one is 2 centimeters, this one becomes what? 4 centimeters. If this one is 9 centimeters, this one becomes half of 9 centimeters. That is what we want to prove today. And for this line, what we are going to learn from this as well is that this side, which is AE, is equal to EC. This one is given, and also this side AD is equal to AB. So by this, it means that the ratio of this side AE, that is AE, please learn that as well, over AD, the ratio of AE to AD will be equal to what? The ratio of AC to what? AB. So learn that one as well. That is, if this one is 4 over 5, this one is 5, this one is, let's say, 9, this one, let's say, 12. It now means that 9 over 4 over 5 will be equal to what? 9 over 12. That is the ratio, which we also need to learn. So let's quickly now go to what we have to do today. We want to prove that this side DE will be what? Half of BC. And going with our guideline to prove, there are just what? 6 of them. The first one is that we state our given, which has been stated on the board. That is the straight line joining the midpoint of two sides of a triangle is parallel to the third side and equal to what? Half the length of the third side. That is our statement, and we have the diagram here. These are what? Our diagram. So after this, we now go to what? The given. So what were we given here? We were given what? Let's quickly go to what? Given. So what were we given? We are given triangle ABC, in which D and E are the midpoints. Triangle what? ABC, in which what? In which D and E here, D and E are the what? Are the midpoints. This D and E, they are what? They are the midpoints of AB and what? And AC of AB and what? And AC. That is this AB, that's the midpoint and what? And AC, respectively. So looking at this, if this and this, if it happens like that, it means that our AD is equal to what? DB. Our AD is equal to what? DB, and our AE is equal to what? EC. So from that, you can say that AD, that is AD is equal to what? DB, and AE is equal to what? EC is equal to EC. So we learned that from that as well. So what are we now to prove? We are to prove that DE, our to prove here, if we go to what? To prove. So we go to prove. Our to prove is that our DE is parallel to what? D is parallel to BC. DE is what? Parallel to BC. Our DE parallel to what? BC, and half of, and our DE as well is equal to what? Half of BC, equal to half of BC. That is what we want to prove. So are we going to have a construction here? Yes, we are going to have a construction. And what are we going to construct here? Please, I'm going to claim this for the construction. So please write it on somewhere. So we are going to construct. What we are going to do is that we are going to have another line that will be parallel to what? BD from here. So we are going to extend our DE to what? To F. So let's extend this one. We extend it to what? To what? To F. And we now have CF to be what? Parallel to DB. So we have this. We have this. You see that? So from here, our BD is now parallel to what? CF, right? So let's say we have a side here. Let's call this one X1. This one, no, let's call this one what? Y1. This one Y2. This one X1. This one X2. So let's have it like that. So we have a side here. We have a side here. We have an angle here. One angle here. We also have one angle here. So this and this. So this one is what? Parallel to this, and as well this is what? Parallel to this. Now from what we have been able to construct. So let's quickly restate our to prove here. Our to prove is that DE is parallel to BC. DE is parallel to what? BC. Not just that, then our DE is equal to half BC. That is our to prove. And what have we constructed? We have constructed what? From C, what do we do? From C, we draw a what? A line. We join it to what? To F. And we extend our DE to what? To F. So let's write that one down. So from C, draw a line parallel to what? Our construction. So from C, draw a line parallel to what? To BD. To BD parallel to BD. Sorry, this was parallel to what? To BD. To meet DE. To meet DE at what? To meet DE at what? At F. To meet DE at what? At F. That is what we have been able to do. So now we now go to what? To prove. To prove. We go to what? To prove. Now. So we go to what? To prove. So that's what we are going to do now. So what are we to prove? So our to prove now. So we have done our construction. So to prove is that in triangle ADE and ECF, ADE and ECF, in triangles ADE and what? And ECF, ADE and ECF. Our AE is equal to EC. Our AE is equal to what? EC. This one is given. This one is given. And then Y1 is what? Y2, that is a vertically opposite angle. Vertically opposite angle. Not just that. Our S2 is equal to what? X1, that is a alternate angle. That is alternate angle. So in that case, it now means that triangle ADE, which I'm going to explain later, is what? Similar to triangle CFE. So this one is angle side from the congruent triangle that we have named. So hence from here, we know that our AD is what? Is FC, and our DE equal to EF. So from here we know also that our AD is equal to DE. So this one is given. So therefore FC is equal to the DB. Also, not just that, our DB is parallel to FC from a construction. This one is what? From a construction. So that one is from what we construct. This one. It's from a construction. So that's where we learned that. So we notice one thing. So we notice one thing from our diagram here. So from this diagram now, we see that DFBC is a what? That is a parallelogram. Look at this shape. DFBC is a what? A parallelogram. From here, we notice that our DB is equal to what? CF. That is what? Parallel side of a what? Of a parallelogram. Not just that, our DF is equal to what? BC. That's what? Another what? Parallel side of a what? Of a parallelogram. Now, and we know that our DE is equal to what? EF. From what we have done so far, our what? DE is equal to what? EF. Why? Because if you consider this triangle ADE and CEF, they are similar. In what? In the sense that this one is x1 and this one is also what? x2, and x1 and x2 they are the same thing. Not just that, which is one angle. This angle and this angle they are the same thing, right? That is angle. Then this angle too, y1 is equal to what? Y2. This is also what? Angle. So this angle and this they are the same thing. This angle and this they are the same thing. So meaning that two angles of this triangle is equal to what? Two angles of this what? Triangle. And not just that. What about this side? This side is equal to what? This side. So meaning that this triangle and this triangle they are what? They are similar. And if they are similar, it means every other what? Every other properties of this triangle will what? Be the same thing. So look at this angle. This angle, two angle. This another angle. So if this angle is equal to this angle, it means that this DE is what? The same thing as what? EF. Look at this angle. This side equal to this side. This side as well is equal to what? This side. And CF is equal to what? DE. Do you get that? That is from the what? From the congruent what? Angle. So if DE is equal to EF, and we know that BC is equal to what? DF. It then means that if you add this, if you add DE and EF together, you are going to get to what? BC. That is DE, look at that, DE plus what? EF is equal to what? Equals BC. And we know that DE is equal to what? EF. That is DE, which is 1D here, plus another what? DE is equal to what? BC. Is equal to BC, right? So we are going to have 2DE equal to what? BC. And what's our DE? Our DE is now equal to 1 over 2 BC. That is what we are saying. That is what we are to prove. So we can complete our notes. So here you learn that this and this, they are the same thing, and the whole of this is what? Is equal to this. So in that case, it means that our DE will now be what? Half of what? Half of BC. That is what we are to learn today. So from that, so we can quickly complete the note here. So hence, DFCB is a parallelogram. Is a what? A parallelogram. So also our DF equals what? DC, and DE equal to EF, which is what? Half of DF, and that is what? Half of DC. Therefore, so that is our DE equals what? Half of DC. So this one is what? Our required. This is what? Our required. So that's our what? Our required. So this is what we are to prove. That when you have a shape like this, so when you have a shape like this, please just quickly know that when you have a shape in this what? In the form of triangle here, what you have here will be what? Half of what you have here. If this one is 10, half of 10 is what you are going to have here. Not just that, the ratio of your AE to AD is equal to what? The ratio of your AC to what? To AE. So please quickly learn that. So there is one thing that we still need to explain. So let me quickly explain one thing before we go to examples. So there is a corollary with this theorem. So let's say you have something like this. Look at this. Okay, sorry. So you have your triangle like this. Look at this. Yes, you have this, and you have something like this now. For instead of this one parallel to this, you now have it like this. Look at this. So this one is now parallel to this. So let's say we have A, B, C, D, E. Now, look at this. So from here, if this one is given, let's say this one is 4, automatically this one becomes what? 4. If this side is not given on its own, let's say maybe you have 6 here, this one is different from what we put the other time. It may not be what? This may not be what? Half of this in this case. It may be more than that or not up to that. If the parallel side that you have here is to this and not to the what? To the entire thing. So please take note of this. But if this one is not there and we now have this, the whole of this to parallel to this, in that case, if this one is 4, this one becomes what? 8. But if the parallel side is not to the entirety of the something, if it is just what? One part of it like this side parallel to this, then in that case it may not be what? It cannot be passed to cannot be passed to this side to be what? To be 8. If this one is 4, it may be what? More or less than that. If the parallel side that you have here is to this place alone, not to the what? The whole of DE, just take note of that. So that is a kind of and every other thing work. Your AC is equal to what? Your AC is equal to your CE, and your AB is equal to your BE. The ratio of your AC to AB is equal to what? The ratio of your AE to what? To AD. So let's take note of that. Not just that too. Even when you have this, the ratio of your AC, if this one is AC, your AC, the ratio of your AC to what? To BC, take note of that as well, is equal to what? Ratio of your AE to what? To DE. To DE. Take note of that as well. The ratio of this AC, this one is, let's say, 2 over 4 equal to what? Let's say 6 over 12. That will be the same thing. So take note of that as well. The ratio of this to this equals to what? Ratio of this to this. Also, the ratio of this to this is equal to what? The ratio of this to the whole of this. So all this work with it with this was theorem. So let's quickly take examples here. We take 2 examples and then we can go to our assignments. So the first one, we have to find the example 1 here. So find the value of x in this diagram. In this what? No. In this diagram. In this diagram. So you have this. You have A, D, E, and you have BC here. So this one is X, this one is 15. So you have to find the value of your X here. This one is very simple, right? It's very simple. What is your X? So what do you apply here? From our theorem, which we know that this one and this one they are parallel, and DE, right, will be what? Half of BC, right? So this one is what? Half of 15. So that is what? 7.5 centimeters, right? So that is very simple. That is very simple. So this one is not that difficult to solve. Please take notes. Parallel. That is from theorem 9. So we can take the second example. We are taking note of this. Okay? So let's quickly go to the second example. I can wrap this one up. So for the second one, we're still to find the value of X. We're still what? To find the what? The value. Find the value of X in the diagram. In the what? In the diagram. So what do you have here? So you have the second diagram, the one under corollary. So you have this, right? This one is what? Parallel to this, and you have this one to be 6 centimeters, right? This one to be X, right? This one to be 5 centimeters. This one to be, so we are not given this. This one is 4 centimeters, and we have S, T, Q, R. And this one is U. So you have to find the value of X. Where is X? This is X. So what do you do here? That is X. What you are going to do here to get the value of your S is very simple as well. Just like I explained the other time, if this one is 4 parallel to this also becomes what? 4 centimeters. Now this one is no longer 8 now. It's no longer R, because the parallel here is not to the entirety of this, it's to just one part of it. So you may not treat this one to be 8. So in this case, this one is 4, this one is now 9. So where are you going to work here? You are going to work with the second proof that we have from the theorem, that the ratio of this over the ratio of this equals to what? The ratio of this over the ratio of this. That is, you are going to consider triangle PTS. We now say that your PT, right, over ST equals to, consider a triangle PRQ now. That will now be your PR equals what? QR equals QR. So that's the ratio you are going to work with. What is your PT? That is X over 4 equals to, this one becomes what? 6 plus X. That is 6 plus what? X over 9. So this is the equation you are going to solve and to get your answer. So let's quickly go. Cross multiply, you are going to have your 9x equals to 4 times 6. What is your 6 times 4? That is 24. So we have 24 plus 4x. Collect like term, you are going to have 9x minus 4x equals what? Equals 24, right? So we have 5x equals 24. What is your x? X is 24 over 5. And that is 5 in 24, that is 4, remainder 4. What is 5 in 40? That is 8 centimeters. So the S is what? Is 4.8 centimeters. So from here, we notice that our S is what? Is 4 point what? That is 4.8 centimeters. So that is our X from here. And it's very simple as well. So this is for the second question, for the second examples. Let me check if we can take one more example before we call it a day. So perhaps we can check question to work with. So let's see if we can see one more question. Yes, I've seen one. So let's take this one as well. Let's quickly take this one. So I can wrap this up. So we take this one is example 2. So take note, this one is example 2. So we're now going to example 3 now. So we go to example 3. So we now have 3. So what do you have in the diagram? We have something like this, alright? We have something like this. So we have something like this. This one is A. We have P. This one is midpoint, not midpoint like that. P. This one is Q. This one is C, and this one is B, right? So this one is 8 centimeter. We have 8 centimeter there. This one is 6 centimeter, right? This one is X, and this one is 5 centimeter. So from here, we're to find the value of our X. What do we do here? So we are still going to apply the same words, theorem 9. So we are working with the ratio here, not parallel. Not this one is parallel to this, right? We know that, right? But we are not to find the what this side and this side. If this one is given, we have to find just half of it, right? That one is very simple. But in this case, we have to find the side of it. So what do? The one I told you that we are going to consider the side. So AQ over AP now. What do you say? AQ over what? AP equals what? AB equals AB over what? AC over what? Over AC. That is what we are going to work with. That is what we are going to work with. AB over what? AB. AQ, sorry, over AB equals what? AB over what? AC. So what is AQ? That is 8 over what? Over S equals what? 14 over X plus 5. So what do you do now? We collect like we are going to cross multiply X times 4, that is 14X equals 8 times 8 into bracket S plus what? 5. So what do we have? We're going to have 14S equals what? 8 times X, that is 8S plus 40. Collect like them. We're going to have 14S minus 8X equals 40, right? So what is 14 minus 8? That is 6x, and that is 40. What is now x? X is 40 over 6, right? So 2 can go here, 2 here, 3, 2 here, 20. So we have 20 over 3. And what is 20 over 3? Oh, that is 6 whole number 2 over 3 centimeter. So that is 2 number 6 over 3 centimeter. So that we what? We give the value of our x, right? So we are going to what? Get the value of our x. So let's quickly take, we call it a day, and we quickly take our question for the assignment. So please don't forget the what? The rule as it apply the theorem. So if you can quickly take a recap of what we have done. So the recap. So you have this. You have this, right? This one is the midpoint. This one is A. Let's say this one is E, F. This one is what? B, C. So from what we have learned today is that this, if this one is 4, this one becomes what? 8. That is 1. The second one is that the ratio of what? AF over what? FE over FE equals to the ratio of AC over what? Over BC, right? And also the ratio of AF over AE over AE equals to the ratio of AC over AB. So please take note of all this. That is what we have learned today. So the assignments, we will see your assignment on the assignment portal. So we say, Assalamu alaikum wa rahmatullahi wa barakatuh.